Good morning, everybody. I do hope some more people show up because it's a much bigger room than there are people in now. I'm going to talk about microservices. Now, this is a very popular subject, but as I don't know yet how much you know about it, this will be shortly. I will do an introduction, of course, and I will tell you some stuff from my own experience, basically. So from what we've done at the companies I work for in the past 2 or 3 years, because it's fairly new. You could say it's a really old idea. I don't care whether you say whether it's an old or a new idea. We just start using it. It's not all good. It's not the silver bullet. It will not solve all your problems, especially not your personal problems. But it's a nice technology, and it can work. We actually made it work, but it took us a long time to get there, right? So it's a long path to actually make. This is a terrible thing. Wait. To adjust the cable here a bit. Okay, I'm still here. So let me first introduce myself. My name is Sander. I'm basically dad. I have 3 kids of my own. My girlfriend has 2 more, so it's pretty crowded. So in my spare time, I sort of do software development. I write code. I'm a software architect, and I talk about it, and I teach people about it, stuff like that. I'll do this really short because I have a truckload of material. I'm not really sure whether I can actually get through it in 50 minutes. I'll try for sure, which means I have to talk really, really fast. So if I'm going too fast, please let me know. Anyway, so I'm an independent consultant. I just started doing that a year and a half ago. I was working for a large company called Capgemini, really, really big company. People often ask me, how many people work at Capgemini? And I usually say, well, almost half of them. And also I became, in this last 2 years, became the CTO of an insurance company. Now that was fairly new stuff to me, which basically means I'm leading them into sort of microservices and stuff like that. This is my personal website, my Twitter tag, so if you feel the need to tweet about it, this is my Twitter tag. It's also the name of my GitHub account. There's not much on there. There's one thing on there. I want to support Michael. Did you see Michael Fetter's keynote this morning earlier when he talked about functional programming? And I did want to support that because I started moving into, it doesn't have anything to do with microservices though, but I started moving into writing in Java and in C#, writing code in a much more functional style, which basically means in the 2 years time that I've been doing that, and yes, I guess it was your question, right? Once you start doing that, moving into writing code in a much more functional style, at first you're like, what is this shit, right? And after a while you start getting it, and after a while you start getting better at it. It's the stuff that, it's the way learning works, right? It's the same, as Michael said, with object orientation. A long time ago, you have to get used to it before you start doing it. It's the same with Agile. When I started doing talks about Agile at first, people were saying, oh, this cannot work. People walked out angrily out of the rooms that I was talking in, right? And it's a bit the same with this functional style of programming. Once you get used to it, you don't want to go back to writing ifs and loops and for loops and while loops and stuff like that. All the code I write these days, and I do have a code example, I just looked it up. It's actually not my code, it's the code of one of my colleagues actually. Not sure whether it will pop up. But I just opened it up just to show you what difference. So this is code in Java. What we actually did is, and again, this has anything to do with microservices though, but so what we did is we created a Java version of the try class in Scala. So if you're familiar with Scala, that's an amazing, it's a monad, right? And we started using that in Java, and we got really good at it. I also wrote a C# version of it, so I have a C# version of the try class from Scala, and it works quite fine. It's on my GitHub account, so you're free to use it. And your code turns into code like this, right? This is just simple functional style coding. So we created a try class, it creates a try success, etc., etc. And we're getting really good at it. Every method I write these days, sorry about that.
Use switch empty operator.
Sorry, what?
Switch empty operator. It's more declarative than is empty.
I know, it's not my code. It's my colleague's code. I warned you about that. And there's always optimization to it, right? You could always optimize even further. Every piece of code I write now, every method I write starts with a return state. Always. I don't have any, well, maybe there's some ifs in here maybe, but this is maybe code of half a year older. And we learn all the time. There's almost no if statements anymore in my code. I don't have any for loops. I don't have try-catch blocks. I don't have while loops. It's all gone, guys. And it makes your code much more robust. So, should you go there? For sure. Look it up. Try and see Scala for the tri-class, etc. Just to back up Michael's talk earlier, right? So it doesn't have anything to do with the subject. And I didn't have enough time anyway, so I thought, oh, let's do this. So basically, back to the slide deck. Right. So this is me, typically at a Microsoft-oriented or a conference. I do Java conferences as well, and then I turn around the pictures, and it makes a lot more sense. I've written a couple of books. They're usually in Dutch, so that doesn't really help you. There's one in English, that's this one. I gave a copy to Naringa, the organizer, this morning, and it's a nice book on Agile. So much for the commercial part. So what I do basically in life, I'll tell you one more story before we get into that. I was working for the Dutch Social Security Agency, and they have this huge COBOL installation. And we were building websites on top of that. And they had to mimic the original black and green character-based screens that they had. So they were not allowed to move away from the page as soon as they already typed something in one of the fields. So I was writing some JavaScript to prevent people to move away from the current tab, from the browser, from closing the browser, etc., etc. So I created some alerts to do that, to see if it worked, and it worked sort of okay. And at that point in time, the project manager came along, and he said, like, you know what, can I do a demo at the client CEO? I said, I'm pretty sure you can, but be aware that there's untested code in the code base. And he was like, yeah, okay, how much wrong can it do? And an hour later, he sent me a screen grab, and it had this alert on it. I'm not really sure where you can read it, but it's not really nice language what it says in here. That's the sort of type I write that says fuck off, basically, but don't record this. But so it's basically, it had untested code. So don't go away with untested code, and this is the stuff I do right out of my code. So let's start off with the monoliths. Now, the thing with monoliths is, the question, a lot of companies come up to me and ask me, so we have this big code base that we want to get rid of. How do you do that? I'm like, I don't know, but the question is, basically, most of the companies I visit, and that's a lot of companies actually, have these code bases that are too big and become unmaintainable, right? They have years and years of coding in it, like they have 25 years of COBOL programming into this 12 million lines code base, and how do you get along with it? How do you deal with that code base? One of my clients is a pretty small company. They build software to refurbish chemical factories, and they have a 3.5 million line code base. Now, for large companies, that probably doesn't mean a lot, but for small companies, having like 20 developers, how do you maintain a 3.5 million line code base, especially when it's written in VB, right? It's Visual Basic. How do you maintain 3.5 million lines of code of Visual Basic? It's ugly, of course, and it's Visual Basic. The problem with it is, so there's some advantages, right? Yet one of the advantages is you have a single language. So as long as you have developers knowing how to write this language that you have, even if it is fairly old, like Java, or COBOL, or Visual Basic, or whatever, but if you still have the developers on board, and if you have a single code base with that single architecture, the architecture is maintained fine, then you're still a bit okay. The problem comes when the code base is so big, and if I change a line of code there, something will break off on the other side of the code, and you don't know. And then you might say, oh, you should have had unit tests all along. Well, nobody wrote unit tests 20 years ago, right? So this code base doesn't have unit tests. How do you do unit testing in COBOL anyway? Or in VB Classic, that is VB6. So the problem is there's all these dependencies in this code base, and if you break something off there, if you add a feature here, it might break off down there, you don't know. This particular client I had, they had SQL statements all over the code, in strings, right? Terrible way to do it. The problem was that if they changed the name of a field in the database, the whole application broke down. It became that fragile, right? Now that's the point in time that you might say, hey, we might have to do something new. Again, another problem they're facing is that they want to write mobile applications now. They don't have a REST interface on their code base or on their database, of course. So they have to change the architecture anyway to do more innovative stuff. And that becomes, even if mobile is still innovative or websites, but they had to change the code base all along. And the problem is they couldn't maintain it anymore. Right now, that is a problem that a lot of companies have these days. And you might say, oh, then we're going to move into microservices, it will solve all our problems. No, it doesn't. It will solve some of your problems, and there's techniques in the whole field of microservices, because microservices is not just one thing. There's lots of stuff that comes out of software development over the past 30 years that you can actually use in this particular technology, or actually that you can use with this particular technology or technique, actually. So, but the big problem is its dependencies. To give you one more example, this is the systems landscape of one of my clients that I worked for a couple of years ago. It's a transportation company in the Netherlands. Every little rectangle in this diagram is actually a system. So they have like 35 systems in this, and all these lines are dependencies between these systems. Now you might think this is not that bad, but this is just the systems landscape from their customer service department. They have more, right? To give you an idea about the size of this thing, this little pink rectangle is called SAP CRM. I'm hoping nobody from SAP sits in the room, but this is big, right? We once counted the tables in the database for this thing. Just give me a guess. How many tables do you think it has? Tables, right? Not records. What's big? 1,000. Sorry? 6,000. That's big. That would be huge, right? It's bigger. Way bigger. It's 142,000 tables in the database, right? That's why SAP consultants are so expensive, right? They have to memorize every single table in the database. Now, this is something that will kill you. This company has a business process that they try to implement. Very simple business process. They have these credit card-like subscriptions, and you could upload a picture to it, so it will be printed on the next card you have. That simple process, for them it should be simple, goes through at least 10 to 12 of these systems, right? It took them half a year to write that. And it took them another half year to test it. Then you know you're doomed, right? This is basically keeping you away from adding new features to your product. And if you have to sell the product to clients, and they say, oh, could you come up with this, and could you come up with that, and you have to say, well, that will take us at least 2 years, then you're doomed. If an insurance company, I work for an insurance company, if they want to add a new product to it, to the systems landscape, they should be able to do that in 2 months. Otherwise, other companies will have created a similar product, and you won't earn any market share. That's the way the world works, right? So, just a brief history, just over time. I started programming in the 80s. And at that point in time, 80s, 90s, this is more 90s stuff, we did client server, right? Now, client server, I guess you're all sort of too young for this stuff. Well, not all of you, but, well, I'm old enough. Anyway, so we wrote code that sits on a desktop computer. Most of you don't even have a desktop computer anymore these days. So the executables, the actual executables, were on the computer, and every time we have to change something, we have to run with a floppy disk to all these computers to reinstall that software, right? That's the way the process worked. And all of the code was sort of down here, because there was no stuff in the middle. There were no application servers or whatever you might have, and there's stuff in the database. And there's nothing in between, right? So what we did is when we changed the code, we sort of copied and pasted, Control-C, Control-V, everywhere, right? And we had different version of the same business logic all over the place, and it grew and grew, and it got bigger and bigger, until it exploded, of course, and it became so inconsistent that we had to kill off all this code, right? And there were crazy computers. I had a computer that had 20 megabytes of memory. 20 megabytes, guys. Then we had to write code to that. My first computer, I just got it back from a friend, I still have it, is a Commodore 64. It had 36,000 bytes free to write code in it. Now that was cool, right? Those were the days. Anyway, so we wrote code in Power Builder, it broke down. So, in the end of the century, people came up with the idea of a request broker architecture. So they put stuff in the middle, and you can say, oh, I'm going to connect my applications in any language using very difficult protocols to this central server, and it did some brokerage. So you could send in a message, and it would distribute it to other parties in your systems landscape. The problem what it was, and I tried working in this project for a while, is that it still was way too complex to do this. For most average organizations, not if you are a large bank having 20,000 developers or whatever you might have, then you're pretty much okay. But even then, it was way too complicated. So we had to start distributing stuff even further. So we moved into the service-oriented architecture era, where we could actually hook up using better protocols like SOAP and stuff. We could hook up into enterprise service buses. And the large vendors all jumped into it, created these things, make a lot of money out of it, and I've been in these projects, and they were okay-ish. Still, the guys having to write the middleware code, they were always the bottleneck, because it always was still fairly much complex. And there was another issue, and we didn't solve that issue with microservices, and we will not solve that issue. It's the issue of semantics, right? I worked for a large bank in that period of time. They were doing mortgage systems, and the idea of a mortgage Well, you all have a picture of what a mortgage is, right? Even if you rent, you know what a mortgage is. The problem was that at a particular client at this international bank is that every department that you spoke to had a different notion of what a mortgage actually is. Right? Some of them think it's your house, some of them think it's the contract, some of them think it's the loan, some of them think it's the life insurance that goes with it, etc., etc. And we didn't realize that until a year into the project, right? And then we sort of built stuff around mortgages and it was totally wrong. We had to redo it all again. Now, the problem with that is semantics, that the same phrase has different meaning in different departments, in different organizations even. So if you distribute it out even further, the problem of semantics gets bigger and bigger and bigger. Right? Until we got to this point that we say now we're in the microservices era, whatever that may be, and we're sort of here, right? We wrote spaghetti code in the 90s, and then we sort of chunked it into larger chunks, having some sort of mechanism in between to keep it together. And now we're sort of in the cupcake era, right? It's like there's all these very small different parts, and they're sort of working together. That's it. Now that's pretty complex stuff actually. So we're sort of like in the mac and cheese era, I would say, if you go into Italian food again. So we have all these little small parts. Some of them are flavored a bit differently. And they're all hooked together in some sort of blurry cheese stuff thing, sauce, whatever you might have, right? And nobody knows what that is. Because it is fairly new, right? Some people say, oh yeah, we've seen this before, we know how it works, we'll put it all together. We tried that. We didn't fail, we succeeded, by the way, so it's happy stuff, but it wasn't as easy as we thought it would be. Maybe it's because we're stupid, I don't know, but it wasn't as easy as we thought it would be. So, let me introduce you a bit about this microservices stuff, right? So, where are we now and what does it do? So, basically, when I heard about this stuff the first time, so this is coming from my own experience, I started reading about it. So, it was like three and a half years ago, and most of the blog posts you saw out there were still a bit like this, right? They were all hallelujah. Like, yeah, this will solve all our problems, and we're going to use it, everybody should use this, blah, 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 decomposing applications for deployability and scalability. Yeah, that's right. Except nobody knew how to do it yet. And then more people started writing about it, people started wondering, what is that, a microservice? What on earth is a microservice anyway? Does anybody know? Are there decent definitions of that? And are there recipes for that? So if you could say, oh, I'm going to build it like that, then I'll have a microservice, and it will work everywhere. They're not, right? This is too new stuff. Big vendors will probably come up with stuff. And then you can see people trying to define it, like this guy says, some in the community even advocate building 10 to 100 lines of code services. 10 lines of code. Does that work? Oh, it could, depending on what you do, of course, but that's really small, right? So they sort of depend the size of that on lines of code, which I think is a horrible metric. And this guy says, well, it should have more than 5,000 lines of code exposed over JSON over HTTP protocol with at most 5 endpoints. What is that? That's an absolute definition, right? It's not relative to what you do. The problem is, it is absolute. It doesn't really work in size. There's no rule that says if your code is smaller than 5,000 lines of code and it doesn't have more than 5 endpoints, it is a microservice. Personally, I don't give a damn whether it's a microservice or not. It has to work, right? That's more important too. And we've came up with very different ideas about the size of these small components that we have. And then important people started writing about it, like Martin Fowler. He writes lots of stuff, and I'll use his definition for a while. People write books about it. Stan Newman wrote a book about it, and there's a few more books coming out these days, but this is sort of the first book. It's a good book. It's very technical. It doesn't show you how to do design, for instance, on microservices. Nobody knows that. And then there's even conferences. This conference sold out in 2 weeks. That's cool, right? And then people started doing training courses about it. See, this is in Russian, right? Can you see the difference between Russian and Ukrainian in the characters? You probably can, I can't, but so it says masterclass, right? And somewhere it says it says microservices, doesn't it? And this is architecture, right? And this is September. And my name is somewhere down there. They spelled it wrong, somebody said. I don't know. I haven't got a clue. But it got really, really popular, right? So then you have to wonder, where are we with this microservices stuff? So you know this graph, right? You should have seen this one. If you haven't, look it up. This is an important graph. It's the Gartner hype cycle. It basically says every new idea, every new technology, like functional programming or OOA back in the days, or Agile, or microservices, or whatever, goes through this particular graph. It says, well, first of all the people are saying, yes, this is the new stuff. We all have to do this, right? This is the great new paradigm that we all use. And then people will start using it slowly, like the early adopters, and they will see that it's much more complicated than it looks. It's the same with functional programming. You will say, well, it doesn't work. Shit, I don't know how to read this. I don't know how to write this. But you have to learn about it, right? And it's the same with every new technique that comes out of it. And people will get very disappointed. Right? You will see microservices talks coming up and microservices blog posts or whatever saying, oh, this doesn't work. Don't do this. Go to the next paradigm. And then everybody will start doing DevOps, right? And DevOps will solve all our problems. No, it doesn't. And it creates even more problems, by the way. And DevOps will get very popular until people start doing it. And they realize there's no way of communicating with these people in the operations department. And then we say, this sucks. Let's move on to the next one. So that's how the cycle works, right? With microservices, I would say we're somewhere on the bend, right? It's somewhere there. So people who do it now sort of are the early adopters. So if you're already doing this, you're the cool people, right? And you don't want to be here, right? You don't want to be the late majority and the laggards and stuff, but people will eventually find a use for every technology, right? There's even a use for Visual Basic. I haven't discovered it yet, but it should be there. I don't know. So this is how it works. And we are really early on in microservices, right? So what are the benefits of it? Well, I give you a definition first. It's Martin Fowler's definition. And he calls it in short. Not really sure that this is in short, but anyway. Let's pick up the most important parts of it, because I have to do this quickly, right? I don't have too much time. Basically he says, microservices is an architectural style. I agree with that. It changes the way you look at things. It changes the way you design stuff. It changes the way you deploy stuff. It changes the way you test stuff. Largely, yes. So it is a different paradigm. It is an architectural style, and you have to find a way how to do this stuff. And he says it's developing a single application as a suite of small services. Now, I'm not really sure about the part about a single application. I'm not really sure what that means. So we have loads of very small applications because we decided to do the applications, let's say the user interface part of it, in very small parts as well. And that helps for us. I'll explain a bit about that later on. They all run in their own process, and they communicate with lightweight mechanisms, often HTTP resource APIs. It's sort of a, you can do this, right? You can say, we use REST, so we have microservices. Now, as I said, I don't really care whether you call it a microservice or not. It's changing the perspective on how you design stuff, and I'm not, if you call it a nanoservice or a microservice or a component or whatever you do, I don't care actually. What I think is important about this definition is this particular part. It's about, these services are built around business capabilities. That means that every one of your components, every one of your microservices has to serve a particular purpose that is small enough and let's say and captured in very small pieces to be able to make this stuff work. I'll explain that a bit more when I talk about bounded contexts. And he says, well, they're independently deployable. Now that is really nice, right? That means I have loads of these things. I think we have like 80 or 90 now at this point in time. And it means that we could literally say that if I have a change to one of these components, let's say I'm changing the internals of a component using a different database technology, whatever I can do. I can do a change, and I can move it through the pipeline, even into production, without changing the other ones. Now that is the big benefit, or one of the big benefits of doing microservices, right? It means I don't have to wait and sort of group all these changes together and then deploy them once a year into production. I can actually say to my users, you know what, if you want to have that button green and on the other side of the screen, I'll have it for you tomorrow in production. At first they don't understand that, by the way, but I'm not going to talk about the cultural stuff. My colleague Kim, who's here, will talk this afternoon, probably also about the cultural stuff, I guess. Oh, she says yes, so that's good. And otherwise I would have to talk about it. That's terrible. So it gives you a whole different perspective on how you could actually work together with your business. And they don't understand that at first. They're like, tomorrow? What do you mean tomorrow? The next release isn't coming up in 3 months, right? You have to do all this user acceptance testing. I thought, well, how much user acceptance testing do you need to do if you want to move the button from right to left and or left to right, whatever for you, and make it green? How much user acceptance testing do you need to do on that? If I change some of the internals of one of my components, how much user acceptance testing are you going to do on that? So it changes the way you work together, and that's good. Basically because of this principle of having these things independently deployable. It also says there's a bare minimum of centralized management. Now, I'm all for that, right? A bare minimum of centralized management. And I don't mean technology, right? This is people. But it's also for technology, right? So there's almost no need for having these enterprise service buses. We use queuing mechanisms, by the way, but that's to be safe in distributed transaction stuff. But we don't have an enterprise service bus in the middle. That doesn't say you're not allowed to have one, because people will interpret this like that. You are allowed to have one, but only if you need it, right? Other than that, it's overhead. And actually, because they're all independently deployable, they all run in their own process, you could actually write them in different programming languages. Now, that might seem really nice. So you can all choose your own programming language, and that's okay if you have 20,000 developers. Not if you have 30 developers or 50 developers, right? If they only know how to write Java, and they don't know how to write functional stuff, I keep coming back on that, but then you don't have to do it, right? Some other people on my teams, they say, well, we want to write C#. I'm all for that, right? But we use Java. All of the other developers only know Java, so why would we write it in a different language anyway? You could say the same for Go, I guess, but I won't. And it also says, but if they all are running independently, they probably also have their own databases, which also means that you can have different data storage technologies for any one of your components, if you want. You don't have to, but you can do that, right? So that's good. So that's the short definition by Martin Fowler. So I'll lift that too a little bit, right? So just to be able to mention the word container, because you have to use the word container in any presentation these days, so I'm going to use the word container a lot in the next few sentences about containers. So this is a container. So if you have these big monolithic applications, if you have to scale them up if they don't perform, what most people will do is they'll spin up multiple instances of the whole application, right? That is really expensive in memory use and performance hits and CPU usage and whatever you might have. And the thing with microservices, if you implement them okay, then you should be able to do more stuff like this. You could say, you know what, one of our components is hit quite a bit more than the other one. So what if we could only spin up multiple instances of that piece of functionality? Now that is exactly what they are for. Right? So you could easily say, you know what, I'm going to spin up 4 of my customer component instances, and 3 accounts, and whatever you do. And then you could go even further. If you could run them in their own process, perhaps in a container. See, I use the word container. Then you would say, oh, run it yourself. Just find out if you're too busy, and if you're too busy, let somebody else spin up another instance. And then we're moving into, there's a newer phrase for that, it's called swarm architecture. It's basically saying, okay, let this thing take care of itself, right? And if it's too busy, just let the whole architecture spin up more instances of itself. We probably move into Wildfly, which is a technology to do that. And you could easily say, well, here is the whole architecture, and by the way, if you're too busy, take care of it. And then the infrastructure will take care of that. That would be the ideal idea, right? So, and the same is with databases. So if you have a monolithic application with a lot of dependencies to your database, like this 3.5 million lines of VB code base, they have over 3,000 locations in the code where they have code that actually connects to a database, right? They don't put it in one place, they put it in 3,000 different places. We just looked at the code and figured it out. And they have a huge dependency on the database all over from the code. So they will never be able to actually pull it apart or split it up into smaller parts. But if you could say, you know what, I have this microservices in place, they could each run their own database, right? Every single component has its own database. So that's not a law, by the way, that's the way we have done stuff. That actually means that you could use different storage technologies for different components. So we started at this insurance company I worked for. We started off having all these components right to DB2. We figured out that we could much better use NoSQL databases. In this particular case, we use MongoDB because it much better works together with these domain models and these bounded contracts that we have in code. So for us developers, it's much easier to write code against. So we sort of moved component to component from DB2 into Mongo. And they all run their own Mongo instance. So they all have their own database. And it makes perfectly sense. And it doesn't have to be Mongo. We just use Mongo for most of our stuff. It could also be that for some of our components, you could write to the file system. For instance, we have a component which is called document. And it basically stores documents somewhere. We couldn't care less whether that's in a database. It's now in a database, by the way. But if it gets too big, we could write it to the file system as well if we want to. It doesn't change the rest of the landscape. We could easily put a new version of the document component into production and say, okay, please use that one, and then it will move and it will put everything on the file system. I have to take a sip. It's really warm. So there are a lot of advantages to it. Like you could say, it's better, scalable, and there's no central governments anymore. I like that. I don't like central governments anyway. I'm a bit of an anarchist, I guess, but it's very high performant if you get to tune it right. It takes a lot of work, by the way. It's easy to build. We can actually write a new component in maybe a day, maybe 2 days. But that's because we use functional style coding, right? I have to come back to that every 3 sentences too. And it's much easier to test because you only have to test these very small components. That is true. There are components sort of range in lines of code. The biggest one's like slightly over 10,000 lines of code because it does it calculates the rates of insurance policies. So it's fairly complex. And the smaller ones, they're like 150 lines of code altogether, right? That is really small. So that means if you have to test an individual component, it is much easier. If you have to test the whole landscape, integrated and all, that is much more complex. Because instead of having a single code base and a single application, you now have 80 to 90 of these things, which basically means the testing complexity rises and rises and rises. So integration testing becomes much harder than it used to be if you have the single monolithic application. So you have to take care of that. So to make sure that, I'll get to the last part of the deck, is that one of the statements will be, test everything automatically, right? Don't do manual testing anymore. Just none of it. I'm quite sure there's no testers in the room. Are there any testers in the room? Oh, only a few. Oh, that's good. Good to have you. Learn how to write code. If you're not already can do that, please learn how to write code. Because you have to write tests and run them automatically, right? That's the way it works. So, but there was a lot of questions about it too, right? So, how big are these things? What technology should I use? Which framework should I use? Blah, blah, blah. I don't care, actually. You can use any frameworks and any technology what you like, as long as you use the same principles altogether, right? And how do you define these messages? Oh yes, it's REST and we use RESTful APIs. Are you working with RESTful APIs? You find it easy? I do now, but it took me 2 years to get that, how that worked, right? It takes a long time, and you have to learn all this stuff. And the problem with this microservices field is that you have to learn a whole lot of new stuff, actually, if you're not used to it already. And the problem also is, how do you deploy this stuff? Now let me get back to that too. So I still have, so what time should I be done, right? Is that in 15 minutes officially? So I won't be able to make it, right? I still need 1.5 hours to explain all of this, and if we're all here, that's good. So the problem is a bit, is where are we going? So if you read this blog from the ThoughtWorks site, if I can see it, they say, well, we are not arguing that we are certain, which is a string sentence, that microservices are the future direction for software architectures. Good, right? And then Simon Brown comes along. Simon's an architect, and he writes, if you cannot build a monolith, what makes you think microservices are the answer? Right? If you're not good at doing software architecture now, the problem will only get bigger when you move into microservices. That is true. And then Sam comes along, he says, well, it's much easier to have a brownfield system, so there's 3.5 million lines of code in this VB application, and to pull stuff out of that is much easier than doing a greenfield situation. He's right about that too. That doesn't mean if you have greenfield that you shouldn't do it. Except if you believe Martin Fowler, because he says all of the successful stories were brownfield, and all of the unsuccessful stories are greenfield. He should come over to our company because we figured it out. But it doesn't mean we have the solution. We found a solution. And there's many different possible solutions. And then Stefan Tilkov, who's German, who's here, he says, well, he's German, so he says, don't start with the monolith when your goal is a microservices architecture. Well, he doesn't actually talk like that, but so he says, what if you want to write code now? Should you write a monolith? And the answer is no, don't, right? Write it in smaller pieces, because smaller pieces are easy to build, easier to test, etc., except that the integration part is hell. So that's about it, right? So the question is this new architectural style our stairway to heaven, or is it our highway to hell? That also solves my musical preferences. And so we've been doing this for like 2.5 years, 3 years now, and I'll show you a bit about what we learned about it. And I'll do it really quick. This is a mainframe. And I'm pretty sure it's the same mainframe type that we have in our insurance company. It probably looks different, right? I haven't seen it, and nobody will tell me where it is because they're afraid I will damage it. And so if you have a mainframe running like 12 million lines of COBOL code in it, there's some issues that you might have. The code looks like a bit like this. It's even worse because it is in Dutch. You know what it is? It's ideal. It's sort of 3GL around COBOL and stuff. It looks horrible. You know how these guys program, by the way? Have you seen this ever in your life? It's fascinating to see that. They have a cursor running up and down on the screen with their keys running it, and they can change every character in the code, and then they'll sort of save it or whatever happens. Magic. It's magic. You have to be a really good programmer to do this. The problem here is that the programs we have, they're sort of aging, right? And they get into, they want to retire at some point in their life, which basically means everybody who has this type of code, either young guns who know how to write COBOL. So if you want to make big money, you have to learn how to write COBOL, right? Because you have to replace all the old geezers that actually know how to do stuff. And you couldn't outsource it because outsourcing gives you the same problem except overseas. So you have to sort of allow yourself to these types. Right? If you go to a typical Java conference, people will look like this. So I grew a beard as well. I got glasses, and so I can easily do talks at Java conferences. It's totally different technology. And you'll end up at a place like this, right? You've seen Nemo, right? Not the aquarium down the road, but the movie. At the end of the movie, they sort of escaped, and they're all in these plastic bags in the sea, and one of them says, okay, now what? So they're into new territory, it changed, and it still didn't help. They're only in smaller packages now, right? They came out in this fish tank and stuff like that. So the thing that you have to do is, first of all, you have to allow yourself to learn new stuff. There's lots of new stuff to learn if you move into this field. And that's fun, right? That's basically why we are in this field. I listened to Michael's talk earlier this morning, and I was sort of like energized, like, hey, this is true. Yes, we can do this too. And we are doing this, except that he put it on a slide, and it makes more sense if you structure it like this. I get energized by that, right? And that's cool. That's why I'm a developer. We can learn new things every day. Isn't that cool? The question is, what did we learn? See, here's Kim. She will be giving a talk this afternoon. And we learned lots of new stuff. First of all, we learned that there's no way that you can set up an architecture and saying, oh, you have to program it like this. Otherwise, we won't get you through the architectural board or whatever you might have. So you have to cancel the architectural board. That's good. And you have to say, we are going to allow ourselves to learn about the software architecture. We set up very, very simple architectural pictures for our small components and our small applications, just to be able to make it change, and it has changed over time. I'll show you the pictures of that, and I'll go through it really quickly. So we sort of got a first slide deck together, like 2.5 years ago, and we said, this is sort of how we're going to do this. This is the only slide with text in it that I sort of have of it. It actually comes out of the original presentation. I'll show you the highlights. So basically, because the organization talks in business processes, we said, oh, we have to implement business processes. And then we said, you know what? We're going to split up everything in very small applications, and these small applications only implement a single business process. Very small elementary business process. Like change your password. We have an application for changing your password. Because it doesn't have anything to do with anything else in the whole landscape. So we can deploy it independently to whatever we're doing. Where was I? Oh, and we also have micro components, basically delivering services. Every one of them, all these applications and all these components have their own domain model. They have their own bounded context. Now, since you're educated much better than we are in Western Europe, you all know what a bounded context is, really? Okay, so it's the same results I get when I ask these questions in Western Europe and around the world. So I'll talk a little bit about it. And we said, you know what, we'll move away from SOAP and XML and all this stuff. And we had fierce discussions with the architectural board, so we sort of canceled them. And we moved it to REST, right? REST opens a lot of possibilities. It also makes things a bit harder, too. Because there's no more fixed contracts anymore, right? It's much more flexible, which means you have to deal with this flexibility of the protocol. So I'll skip this one just to save a bit of time. So we model our services into little diagrams. And then we have this very simple architectural picture. This is the actual architectural picture from the original presentation. We said, you know what? All of these very small applications have this stupid architecture. There wasn't anything else in the document. This is our architecture. And the way you solve it, figure it out. So it basically means, if you look at any one of these small applications, they have the same simple software architecture. You could see it in the packages in the code as well. If I would be able to do a 90-minute talk, I could actually show you the code. That actually sort of confirms or adheres to this. So it has a presentation layer, it has use cases in the process layer, it has a bounded context in the domain layer, and this is the most important part of it, and it has some code out that goes out into services. So this is an application, it has user interface, and it only talks to services and components. It doesn't have its own database. None of the applications do. That's one of the sort of the rules that we picked. And the same is for our components. They look the same, right? It's the same architecture, except that they have a service interface with resources in it. And they also have use cases implementing these services and a bounded context in the domain model, and a way to go out into, let's say, databases, their own database, or into other services. That's the whole architecture that we use. Now, any one of our components, depending on whether they were written 2 years ago or whether they were written last week, they all adhere to this architecture. That means if we add new people to the team, which we occasionally do, it will be easy to show them this is the architecture, and it has these patterns in it, all these patterns from DDD and stuff, and show them, okay, this is where it is, find your way into it. And depending on how much our technology has evolved, the code will look slightly differently, but it will be still in the same place. So we now moved into functional style programming, so most of our code looks like that, and it didn't do that when we started doing this 2.5 years ago, right? So the code base for each of these little repositories is slightly different, but it adheres to the architecture. So we keep the architecture as clean as possible. And I would say that is a definite recommendation. Then you have to talk about the design of this stuff. Now, we sort of discussed this for quite a while, and we figured out that there's a very important pattern to see with our applications and our components. And we said they all have their own bounded context. So I'll talk a little bit about the bounded context. Skip this one. And about bounded context, I don't mean these ones, but I surely mean coming out of these books like this, right? In Bob Martin's book, Agile Software Development, he describes the single responsibility principle. And if you look at it, it basically says that every module, whether that's a class or a package or a component or a module, should have responsibility over a single part of the functionality provided by the software. That responsibility should be entirely encapsulated by the class or the module or the component, etc., etc. So it's about encapsulation, right? And if you look at it, it sort of boils down to these two. He says, well, group together things that change together. That doesn't mean the data changes, it means the code changes, right? So if the code changes for this speed of code, and at the same time, it changes something there, they might belong together. That's an indication that they might belong together. So that might be a good idea to group them together. We sort of had this. We had a product component, and it first consisted, it has insurance policy products definitions in it. And we first of all picked it out, and we sort of created 4 different components for the product and the objects that were insured, and the coverages, and the clauses and stuff like that. And they all changed together. So over time, we sort of grouped them together into the same resource, just getting a product definition, get the whole JSON object out, that's it. And then later on, we discovered that one part of that, we also needed it from somewhere else in the landscape. And it didn't change anymore, while the rest of the definition still changed. So we pulled that one out again. So it's sort of dynamically grouping and regrouping of your resources. And basically the same thing says it's separate things that change for different reasons. So you separate out stuff that doesn't belong together, basically. It's still a bit vague. And then we figured out that the bounded context pattern from the DDD book, which you should have all read, right? If you haven't, steal it somewhere, borrow it from your colleague, buy it even, or download it, whatever you do, read this stuff, right? It's good stuff. Most of the patterns that we use come out of this book. The most important pattern would be the bounded context pattern. When I first read the book, quite a while ago, I didn't realize the importance of this particular pattern. I was much more into the other patterns, and I couldn't figure out what this meant. And it wasn't until Microservices that I really read this stuff, and I thought, hey, this is what he meant. The archivist himself, he sort of says, basically, Microservices is the best way to implement DDD. That's an interesting thought, right? It's not the other way around, but it's the way it is. So, to give you a very simple example about this stuff is that if you have this model, this is my very big, a very complex, unified domain model, right? But the problem is with the word unified. It says unified here, right? Somewhere, here. So, the unified model, which basically says, this is all of my business, and I'll put it in one big domain model, and if I put it in one big domain model, everything's there. The problem with that model is that there are elements in that model that have different roles in there, right? So in this particular case, in this very, very complex domain model, basically the product class has two different roles. It has to do with updating your stock, and it has to do with selling stuff. And that means it has properties and behavior from this side of the model, and it has properties and behavior from this side of the model. And that means if I want to go into a different direction with this particular part of the domain, I have to take into account that this still is also there, right? It's become dependent on that. And what you want to do, actually, is break that dependencies up. Look for the items that have different roles in your model and break up your model there. So you would be able to change it in two different domain models, two very small domain models, with a very minimal communication. See, it's so minimal, it doesn't even show on the diagram. Well, that is minimal, right? So now you have two different bounded contacts, and they can move in very different directions without touching the other half of it. Now this is a fairly simple example, but if you have a more complex domain, like the 3.5 million lines code base, they have like 650 tables in the database. Again, for 20 developers, that's quite a lot. You have to maintain it. And we started pulling stuff out. We first started pulling stuff out around logging in. So we had a user, an account, and stuff like that. And then we put the second part out about licensing, and then it became more technical into their domain. And they split up parts from that domain. And I rerouted all the code to those new parts. And they slowly degraded or disintegrated the big code base that they had. Until now they got to the point they said they had desktop applications, and they said, hey, we're now able to write web applications as well, let's do that. They're sort of abandoning their old desktop application. And that's a good thing, because they have to move into the future. So this is, to me, the most important principle about splitting up into microservices, about the design of that stuff. So I'm running out of time, so I'll do this briefly. And again, we did the same with the resources. So this is basically one of the domain models of one of our components. Again, it's in Dutch, I'm sorry about it. This insurance company is pretty much Dutch, so they do everything in Dutch, which makes the code unreadable if you're not Dutch. I guess that's part of the goal. But anyway, so this is the domain model, and we created services around that domain model, because this is the domain model of one of its components. Basically, we figured out a way how to draw models for this as well. We use them slightly to generate code of it. We generate most of this stuff. And we figured out a way to model all these small components and their resources. And here's an example of the same model, but then the resource model for this particular component. It has a resource that starts with declarations. So there's declarations. If you add the ID to it, you get a single one. And if you add results to it, you get the results of that. It's not a declaration, it's like a questionnaire. You get the results from that, and you get a set of results. So we modeled it out. Probably people will find better ways of documenting stuff. When we started doing this, we didn't have one. So this is the way we model this. Because if you have like 90 components in your architecture, and it will grow until like hundreds, you have to find a way to document that in a consistent way, sort of consistent way. So we did it a bit like this, and it works for us. Our testers use this to write test code that actually calls on the URLs and says, oh, do we get this one back? If that's true, then it works, and we run these tests automatically all the time. And the next thing is, we said we will do REST, right? Now, REST is not as easy as it looks like. It seems to be pretty much standardized. It isn't, right? There's no standard definition of what is REST and what it means to be a RESTful API. There's sort of ways of doing that, but if I ask questions about what is the status code that you get back if you do it like this and this and this, people will give you different responses. I tried it with audiences around the world. There seems to be sort of agreement on how to do this stuff. So depending on which verbs you use, and the data you pass in, and the query parameters you pass in, and the way you build up your RESTful API, it will get different results. I didn't create it, I found a cheat sheet for that. So this is basically how it works. So just memorize this, and you know everything there is to know about RESTful APIs. This is good. Basically, this means you've sent me the wrong information as a component, so the component receives the wrong information, and this basically means the component doesn't know what to do with it. We fucked up as a component, right? So remember this, you'll be fine. But in general, remember that RESTful APIs are much harder than they seem to be. That's how we figured it out. And then there's Postle's law. Basically, in REST, you get JSON objects back if you agree to do that. And these JSON objects might have different properties than the ones you want to receive. So if the JSON object that comes out of the component has like 5 properties, you only need 3, you need to figure out a way to deal with the other 2, right? You need to ignore them, for instance. That's what we do mostly. It could also be the other way around. It sends 5 properties and you have to have 8. Where do you get the other 3 from? So you have to be very flexible about what you get back from the component. And it might change over time, right? Don't try to minimize these changes because it will break your interfaces, etc., etc. I have 3 more subjects. I'm already running over time. If you're okay with it, I'll try to do that before 11:30, 11 or 12:30. I don't know. There's a time difference. So think about testing. So you're testers, right? Most of the testers I know, they write manual tests. They do manual testing, right? They click on buttons and they see whether the outcome is as they described in the big Excel document. That's terrible, right? No? Is that not terrible? No. I agree. It's not how you should test, but let's say in the Netherlands and in countries around us, a lot of people still do this. And my opinion is that if you are testing like that, you're getting it wrong. Basically because if you do a microservices architecture, that means you have to test each one of these components, each of your applications, and you have to test the integration of them as well. There's no way on earth that you can do that with manual testing. So you have to automate all the tests if you do microservices. Because every little change you have in the landscape, every single piece that you want to deploy through it, you have to test into integration. If you don't do that, you'd never know for sure whether it actually works with all of the other components and all the other versions of all the other components. That means you have to automate all your tests. And whether you do that in code, or whether you do that in using Selenium or using tools for that, I don't care, but you have to automate everything. Everything has to be in the pipeline. It has to be automatically tested. So that's basically how it works. And if you test, make sure of this. If you fail, failure is not bad, right? Failure is about learning. That means the best way to do that is to fail as fast as possible. That is, as developers, you have to write unit tests for all your code. Because if they fail, you see it immediately, right? And once you check in your code, the rest of the automated tests start running. And when they start running, you want to get feedback still as fast as possible. Because keeping the feedback loop short is really vital to software development. So that means, as a simple software development lifecycle, this is basically ours, but you will explain a bit more about it, I guess. It doesn't say use this one. This is just an example of how we do stuff. We do some design, we write the code, we write unit tests as well. Oh, I think I got that in the picture, right? Yeah. So we write a unit test, somebody else does peer reviews, and we're looking at tooling for that right now. And then it gets deployed, and all the other stuff are run automatically. We test the use cases, we test the components, the rest interfaces, etc., etc. They integrate, so they deploy it again, and they move it into the integration test. All the scenarios get tested automatically. That's basically how we do it, right? And in the end, there's still the product owner who says, yes, it's okay. We click the button, put the stuff into production. That's how we want it to be. That means, even if your testers are brilliant, I'm quite sure this guy's pretty brilliant. Not really sure you can still smoke in the Netherlands in the office, but all this manual testing stuff, there's no need for it, except that when I'm writing my code, the tester is sitting next to me, or in my current situation, he's sitting in my bag, and I look at my code and I'm saying to him, could you please check it now whether it goes on? He says, yeah, it looks okay, let's check it in and see if the test runs. Done. That's the only manual testing we do. It's immediately on me writing code, or anybody else writing. So this is basically what we are using for our current tool set. Just to give you an example, we write our unit tests with JUnit and Mockito and Empress and stuff like that. And we run Sonar to do QA stuff. Nice tool, by the way, especially the latest versions of it are really, really cool. We define our contracts using JBehave and Serenity and Selenium to do our integration testing and scenario testing automatically. And it all is in our deployment pipelines. It took us quite a while to set that stuff up. So user acceptance testing, I don't see the reason for that anymore. It also saves a lot of time. So the users are there, they're there to define the functionality. But because you're writing it in very small pieces, the outcomes are there the next day, right? So they still know what happened. And if they already agreed on the part of the design, there's no need for additional checks anymore, I would say. Sometimes there is, but not quite often. Then if you want to deploy this, but we will talk a lot more about this, so I'll do this really, really briefly. You are moving into very different environments, right? You have to have your development, the test environment, the integration environment, your acceptance environment, stuff like that. We sort of stopped maintaining these environments and sort of creating them again every time. Our infrastructure is code as well, by the way, these days. So we can create a new environment every time we want to. That's why we're going to. We're halfway, I would say. So we moved into different environments every now and then, and that means we deploy it every time again and again. And in every environment, different tests are run. And the longer the tests run, the later we run them. Most of them we run at night. We run the whole circus at night. And the rest of it is run every day. So the problem with it is, if you have microservices, you have different pipelines. You could have different pipelines for any one of your components. So we ended up having more and more of these pipelines. This is just a Jenkins screen product, which I sort of redid the UI because I hated the original UI. It looked like the 80s. But you get pipelines for every one of your components, with every component, with every application. So instead of having one pipeline to rule them all, to have your single code base run through, you get more of them and more of them. And in the end, because they also have different versions of components who have different life cycles, it sort of becomes something like this. It becomes hard to maintain your pipelines. You have to do all these settings, and Jenkins is not really a nice tool to sort of maintain that. So you have to think about creating templates for pipelines. Or you have to find a way to clone them. Because if you have 80 pipelines, and you say, oh, okay, we want to add Sonar into this particular moment in the pipeline, you don't want to update 80 or 90 pipelines, or 300 if you have 300 components. So that means you have to change the way you look at pipelines. So we looked at mechanisms to create templates for pipelines and be able to clone them. So we could add new steps to the pipeline, or change steps, or change the location where they are deployed to at one point, and then everybody, all these pipelines are sort of recreated. And we figured out, we looked at all the technology that was there. So we started looking at Jenkins, and we figured out that Bamboo might solve it, and we looked at TeamCity, and we looked at ThoughtWorks Go. And now we're back at Jenkins again, but only using the cloud-based version, so the enterprise version. And it sort of halfway solves our problem. So there's lots of stuff to figure out if you're looking into these microservices deployments as well, because you have to have all these pipelines. It's a pain in the ass, basically. It took us quite a while to get there, actually. And again, working with these operations people, to me, it's not a big joy. I just feel like I don't know how to communicate with these guys because they look at the world differently than we do. Right? They talk in different phrases. They understand different things than we do as developers. I'm not much of an infrastructure guy, so I sort of feel like being on the wrong. I was the original product owner for our operations team, and I sort of moved that out because I couldn't find a way to talk to them. So it's sort of a cultural change a lot. Now the last topic, I have to do this. The thing is, if you start doing this, there's even more you could do with it. You could change your whole culture in your organization. Instead of saying we have these quarterly releases, a lot of companies still have that, or annual releases, which is even worse, which the company that built the product for refurbishing factories, they only release once a year. How hard is that, right? It makes stuff so hard because you grab together all these changes and you have to test them all together, right? It's much easier to do one small change and move that into production, and then take the next change and move that into production, etc., etc. That is much, much easier. So the thing is, you have to be aware that having changes implemented in very small steps is much easier than saying, oh, we gather them all together and at once, we're going to deploy it all. That is so much harder. The same goes for writing code. Let's give you an example, right? This is my Twitter feed from a while ago. And it looks quite nice, right? They figured out a nice UI framework and we built it quite nicely. So what if they would have built this as one product? Say, well, we're going to take 5 years, and in 5 years we'll put something in production which is really nice. You can all use it. They would probably now have like 10 users in the world. Right? They'll probably would have released it last week or something. Instead, they didn't, right? They created the very first version, which looks horrible. This is the first version of Twitter. Right? It doesn't make much sense, but it worked. And then they kept on adding features to it. So most of you probably use Gmail. Who of you used Gmail for more than 10 years? Now, you might have realized that they changed a lot over time. But because they're all very small changes to it, nobody realizes it. It's very different from, let's say, Microsoft Word. There's a new version coming out every 2 years, and they totally change the interface. Let's put it nicely. Change the interface, and then you figure out how it works. Every time they say, well, with this new version of Office, you're 90% more productive. What does that mean? 90% more productive for writing documents? Anyway, and it has a lot of features that nobody in the world uses, right? Have you figured out how many features there are in Word? Have you ever used all of them? Nobody does. Right? You just type it, just save it, that's it. Maybe some forwarding, but that's it. So they could have done it much better. The way to do it is to look at this particular picture. The way most companies build software is the line above. They say, we are going to build a set of cars. We're going to get 20 cars fully featured, and after it's done, we'll release it. Now that is very, very difficult. Let's say you could talk to a client. You could say, you know what? We'll build it feature by feature. For every one of these features, we'll build a skateboard version. It looks like shit, but it will work. And you could say to the client the next day, once you finish this, what do you want us to do? Do you want us to create a bicycle version of the first feature, or do you want us to create the skateboard version of the next feature? He'll probably say, build me the second skateboard. And he might say, build me a bicycle of one of them. So in the end, once you get the same product out with the 20 features, you might end up with a product that has like 16 skateboards, 2 bicycles, and 2 motorcycles. And it will be much cheaper and finish much earlier than you would do in traditional products. Right? So that's a big, big difference. And microservices, being all very, very small, into very, very small pieces and being able to deploy every change, allows you to do this stuff. So, I'll cut this short because you want to go out to the swimming pool, I guess. So I'll skip this part on, I'll go to the retrospectives because it adds on to this. So the thing is with microservices is that it isn't just one thing. It's not just an architectural style. It can change a lot of the perspectives you have on software development. It can change the culture in your organization even. It takes a while, by the way. So my statement is, I don't really care about microservices. I care about good, clean code that is easy to deploy, easy to test, and flexible, and it's highly scalable, and being able to do different things than these big projects that move items out. And microservices is a great style of doing that. And you can pick any one of the parts in there, any one of the things I just mentioned, or the rest of them that is out there, because it's very hard to do that in an hour, and pick out the parts that are important to you. Like, if you want to create more modular design, look at the bounded context parts, and look at the way you can design this thing. If you want to be more flexible, more scalable, look at individual deployment. Look at Docker containers or whatever you do. Oh, there's the Docker word again. Write functional code. If you want to have different database styles on different parts of your software, look at it too. That's a good way of doing that. So there's different things you can pull out of this microservices architectural style that will help you move on into the world. Does it work? It does. This is an example I have. I took 60 developers in Romania, I guess. They all use different frameworks and different technologies. So we're Java people, .NET people, Node.js people, front-end people. And we built a dating website in 2 hours. The only thing I had with me was a router. And we all connected to the router, stood them up with different teams, and we built software in different languages, different frameworks, different databases. We added it together. It sort of worked. That was a pretty cool result. So it can work. But it takes a whole while to get there. It took us 1.5 years about to get stuff on the road. We are in production with versions, and we update our versions again and again and again. We're sort of now here. And it took us 1.5 years to get there, because there's a lot of stuff that you need to figure out before you can go into production with this stuff. If you do that, do minimal viable products. That, by the way, goes for any piece of software you build. And if you do minimal viable products, there's one last thing I would recommend is stop doing projects. Projects don't work with software development. I'll try to show you that really briefly. I could spend the whole day talking about this. Allow your team to learn and always have fun. And now I'm done. I'm sorry to keep you from coffee and beer or whatever.
Thank you. It was a great talk. My question is, how do you decide whether to share scenes like libraries, or whether to deploy them as services and share as APIs?
That is a good question. So the question is there still reusables in code, right?
Yeah.
What we did, and we figured out over time, is that if you start sharing, for instance, if you have a collection of shared domain objects, a lot of people are inclined to do that and put them in a separate library. If you do that, that means that your components, and well, every application component that uses that library, they are sort of tied together, right? And the thing is, if you want to have your components to be able to have different clients to use the same component, you don't want to get it stuck into the same definition. So what we did is we did not create a library of domain objects. We have a shared library for technical stuff, for dealing with REST response, stuff like that, with requests and UI stuff. That sort of stuff we sort of put into separate libraries, and they're in every war and every jar that we have. But none of the functional stuff is in there, except for some enumerations. But I'm not really sure about that, but it has to do with how we serialize and deserialize stuff. And some of the value objects that we have, like an IBAN value object or an email value object, stuff like that is sort of easy to keep it out. That's the only functional part we share. The rest of the domain object product here is totally different from the domain object product that you have in that component. So we don't share functional stuff. We do share technical stuff, but not the functional stuff.
Thank you.
You're welcome. I think he was first.
Thank you. I have a question about how to handle cases when, let's say, one microservice that exposes REST API goes down, let's say, for deployment. How other services should handle this situation? Like, should they retry a call? How should they recover from the failure? Thank you.
What to do on failure when components are just gone, right? It depends on the situation. There's no general answer to say you always have to do that. It sort of depends on the scenario you're in. Some of the scenarios it might be worthwhile to retry. Maybe they've come up again. And some of them you have to go into a fallback scenario. What we did is for scenarios that we, where the process is blocking because of the non-availability of a component, we use queuing. So we have used ActiveMQ for that, and we have error queues. So that means if the process cannot continue, it's put into an error queue, and it will try again later. Or an operator has to look at it and try it again later. But it sort of depends on the situation. For instance, if our account service is down, which we use for login, you're doomed, basically. And there's not much you can do than say, yeah, we're sorry, we're not there. So it totally depends on the scenario that you might use. Some of the processes are not blocking at all. Some of them, you can use parts to do them asynchronously. So there's different solutions for different scenarios.
Thanks for the talk. My question is, how do you deal with different data views and data flows? Do you use any techniques like event sourcing or something like that?
Not yet. I hope Greg isn't in the room, but we might look into that in the future. We don't have a need for that now. The big thing is, don't do stuff that you don't need right now.
Yeah.
Stuff out. So we haven't used it yet. The thing is that because of every component has its own bounded context, so its own domain model, we can deal with the differences between these domain models quite good. And it's basically the REST API, the technology around it, that sort of serializes and deserializes stuff. So that's the way we work with our data. And when the data gets bigger and bigger, we might move into using event sourcing. And we could try it out for a single component, for instance, right? And say, okay, this component is going to do that.
I see.
And then we'll look into the next.
A connected question. For example, you have product, different instances of product in different bounded contexts, like you described. But you have a product name, for example, which is a kind of shared between these two bounded contexts. What's your approach? Are you doing an API call into some centralized product instance?
That's what we have. But again, that depends on the situation you have.
Okay.
For us, that works because product definitions are sort of like read-only. They're just there, right? We don't update them. They're just in the component, so we can just ask for it. And that's the port where we have the definitions. They're in one place.
Okay. Yeah. Thank you.
Oh dear.
Thank you, mentioning myself every 5 minutes. So question to you. I was not even born when Unix-like philosophy exists. For system stuff, there was subject-oriented philosophy for code stuff. So my question is, don't you think that your generation fucked up understanding Unix-like philosophy, building software at scale?
Probably.
Thanks.
But again, wait. But your generation will fuck up too. Are you using JavaScript?
No,
Good.
it's impossible.
JavaScript will be the next legacy, guys, and we will have a very hard time maintaining that. So you will be the next generation COBOL programmers. You will have to maintain JavaScript for the next 40 years. So you're much worse off than I am, right? Okay, what was the rest of the order? Yeah.
Yeah, that was me. So I wanted, first, thank you for the talk. I have a question. So microservices introduce additional complexity, like you do have like asynchronous code, the failover scenarios, and so on. So I'm wondering, like, what are the use cases for them, and when you wouldn't even recommend to use them?
To use what? To use?
Not to use microservices and go with the monolith, because basically the microservices would add you additional complexity.
True, a lot.
And in some cases, basically that just doesn't make sense to have them.
Yes, that's true. So it's not. I'm not saying go and use microservices for everything. That's for none of the paradigms that are out there. Microservices work, or your paradigm works all the time. Okay. So there's a reason to do stuff. First, figure out what the business case would be. So what are the actual issues that the organization has? Like, is the software not really scalable? Is it not flexible enough, or is it very hard to maintain? So there's very different arguments for moving into a certain field. For some of these arguments, like scalability, deployability, being able to do modular design, microservices is a good answer, but it's not an answer to everything. So there are situations, yes, that you could still do a monolithic application, for sure, but you have to keep your architecture clean, I would say. So that's a short answer. For the long answer, I have to do another hour, right? So I think this guy was first. Yeah.
Thank you for the talk. In what way you recommend to split one legacy large database with foreign keys and other references between tables into some databases? How to be with integrity checking?
Well, look, the bounded context pattern I show you, where some of the objects in the database have multiple roles. That's where to start, right? That's where you could split stuff up. Split them up into two. You will see that if you split those up, that they'll probably get different names to that as well. For instance, the example I mentioned that it has stock in there. So it's probably a stock product and a sold product. So the different roles, you could actually name them and split it up there and put that into different components. And the only connection between them is they could have a shared key, or one of them could have a foreign key to the other one. It's basically just the ID that you share. And the rest of them, you could split that up. It's not easy, by the way. It's hard work. But that's the pattern to look for.
Hi, thank you for the talk. And I think it's not a question, and I'm not criticizing, but I can't agree with the fact that deployment with microservices is easy. It's easier because, but there was a sentence on the slide, because when I deal with monolith, everything I need to do is just spin up one new
Wait. There's no sentence on the slide that microservice deployment is easy. It isn't.
There was.
There was? I should check my slide, but no, it's...
Okay, probably I'm mistaken.
Oh, good. No, because it isn't easy at all. It's much harder. That's why the difficult parts on microservices are basically integrating stuff, testing everything automatically, and deployment. Deployment is much tougher. It takes a long time to get it right. No, it's hard. It's hard, actually.
Hey, Sander, thank you for the talk, and
I guess I'm recording for you now, so that's good.
the question that I think you skipped in the presentation was, how do you monitor, how you make the operation actually? Okay, you see that service is not working, but having many services, of course there are many talks, but I would be interested in the solution you are using currently.
be able to recreate the instances. We monitor all our logs continuously, so we can see it, and we actually put dashboards on top of that. But to be quite honest, if you go to Kim's talk in the afternoon, we should probably talk about the Elk stack and stuff like that, Elasticsearch and Kanban for using dashboards and stuff like that. But we use that to monitor continuously. And there's lots of stuff you can try out, but we're still trying out to do that. We're not there yet for that part.
Всем спасибо, мы перебрали 25 минут, получается, так что через 20 минут продолжаем.